Hey there, everybody. Welcome back. We are starting chapter 6 today. Chapter 6 is on linear equations in two variables. And this is where we start doing graphing and in the big graphing things on the rectangular coordinate system, also known as the Cartesian coordinate system. So 6.1 is on the rectangular, also called Cartesian coordinate system. So linear equations in two variables, the standard form for two variables, standard form for linear equation in two variables. We do ax plus by equals c, where these are two variables and a, b, and c are constants or numbers. Okay. Solutions to these equations. They go by a couple names. They're called coordinates, points, or ordered pairs. And they come in the form parentheses x, comma, y, and parentheses. So before we get into graphing and looking at the rectangular coordinate system, let's just see what we're talking about here. Let's say we have 5x plus y equals 9. Is -2, 1 a solution? Well, the way we find out is we plug it in. This is my x value. This is my y value. So I have 5 times parentheses plus parentheses equals 9. I'm plugging in my -2 and 1 for my y's, x and y. I have 5 times -2 is -10 plus 1. Does that equal 9? -9 does not equal 9. So no, it's not a solution. So well, that makes me think, well, what would work with, like, let's say, what would work with -2? I can find a y value that -2 would work with. What we're going to do is we're just going to plug in the -2 and leave y by itself and solve for it. So this would be -10 plus y equals 9. And I add 10 to both sides. And I get y equals 19. So this means -2, 19 is a solution. What would work with my y equals 1? Why don't you guys try this here and see what x value would work and write it as an ordered pair. All right. I'll assume you did. We have 5x plus +1 equals 9. I'm going to subtract 1 from both sides. I get 5x equals 8. Divide by 5, and I get x equals 8/5. So my ordered pair for that one would be 8/5, 1. Okay. That's how we check solutions. That's how we find solutions. One way to find values. You're going to see, we call them linear equations because when we graph them, they make a line. And not a flat line like we've been doing on a number line. No, it's going to be a graph with a line. So let's talk about the Cartesian coordinate system. Maybe let's make a table first. Let's practice that skill a little bit more. 3x minus y equals -2. And maybe we'll try y equals -1/3 x plus 2. Let's make a table of x, y values that work. You'll find that a good way of doing it is find where x equals 0 is a good way. Y equals 0 is a good way. And maybe try a point around x, -1 and +1. So if I do this here, if I plug in 0, 3 times 0 minus y equals -2, y equals -2. So y equals +2 when I multiply both sides by -1. So that gives me the ordered pair 0, 2. If I plug in y equals 0, I have 3x minus 0 equals -2. Minus 0 doesn't do anything, so we just have 3x equals -2. Divide by -3, and we get x equals -2. Not -3, divide by +3. We get x equals -2/3. So that gives me the ordered pair of -2/3, 0. If I stick in 1 and -1, 3 times -1 minus y equals -2. -3 minus y equals -2. This is actually quicker if I add y to both sides and add 2 to both sides. I get -1 on the left and y on the right, so y equals -1. This is -1, -1. And when I plug in x equals 1, and do what I did last time, add y to both sides and add 2 to both sides. And I get 5 equals y. All right. If I were to do the XY table over here, it looks like 0 wasn't helpful, but these ones turned out to be pretty good. I'm going to still do the 0, and we'll talk about y in 6.2 while we're doing it. But now I want to pick numbers. I don't want to end up with fractions if I can avoid it. So I'm going to pick a number for x that cancels this fraction. I'm going to do +3, and I'll try -3. Those will cancel this fraction, and then y won't be a fraction. And you'll see why when it comes to graphing why I chose to do that, which we're going to do on the next page. So if I stick in 0, I get y equals 2. And I get the point 0.02. If I stick in y equals 0, I subtract 2 from both sides. I'll multiply both sides by the reciprocal, which is -3/1. And I'm going to get x equals 6. And now we'll do The positive 3 and the negative 3. Y equals negative 1/3 times 3 plus 2. This is negative 1 plus 2, which is 1. And if I put in negative 3, x equals negative 3, get y equals negative 1/3 times negative 3 plus 2. This is positive 1 plus 2, which is 3. So I get the points 6, 0, 3, 1, and negative 3, 3. As you can see, there was less work to do when we had y by itself. This is one of the reasons we talked about doing those literal equations in 5.7. This is one of the primary uses for it. So we'll do more of that later on in the course of this chapter. But you'll see generating the table was easier in this form. And it even helped me figure out ways to avoid some fractions by seeing it this way. Now let's talk about the coordinate system. And I'm going to use those values in a second, so I'm just going to put this off to the side for now. And the fan's trying to blow it, so I got to weigh it down. There we go. Let me wet my whistle. So our Cartesian coordinate system. We have a vertical line. This is called the y-axis. We have a horizontal line, and this is called the x-axis. As we move right across the line, x gets bigger this direction. And left across this line, x gets smaller over here. As I move up, y gets bigger. Y is positive in this direction. And as we go down, y gets lower. Y is negative in this direction. All right, I had two sets of ordered pairs. I'm going to do them in different colors. So one color was, the first equation we did was 3x minus y equals negative 2. And we had the points 0, 2, negative 2/3, 0, negative 1, and 1, 5. And for the equation y equals negative 1/3 x plus 2, we had 0, 2, 6, 0. We had 3, 1, and negative 3, 3. Okay, so in the very center, this is called the origin. The center is called the origin. That's where x equals 0 and y equals 0. That didn't say origin very well. I wrote it all funny. Or just 0, 0. As I move up, the y value changes, but the x value doesn't. This point here, I'll do that. That's the center. This point here is 0, 2. As I go left from the center, x changes and goes negative. Negative 2/3, 0 is probably there. Since I don't have, this is a 1, this is, helps to put some scale on this, 5, 5, negative 5, and negative 5. If I do -1, -1, I got to go left from the center one and down from the center one. Left one, down one. That's the -1, -1. And here, this is my x value, this is my y value. To get to it, I go to where x equals 1, and then I go up 5 for where y equals 5. And that's right there. And you'll see the dots, and this makes a line. There are a lot, an infinite number of values that will satisfy this equation, but they have to be on this line. If I do the other set, 0, 2 is right here. 6, 0 is over here. I had 3, 1 is right 3 and up 1. So x comma y, x is positive this way. So 3 in the positive direction, 1 up. And then I want to go 3 in the negative direction on x and up 3 for that. It looks like I can connect the dots here. All right, it's a little bit more information. That's how we graph lines. That's how the ordered pair works. So up here was 1, 5. Over here was -3, 3. We got -1, -1 down here. This was 3, 1 here. We didn't have a point on the line that was in this area, this quadrant. But if I go right 2 and down 4, this would be 2, -4 here. Each of these regions makes up a quadrant. This is called quadrant 1. We generally just say Q1. And actually it goes counterclockwise. This is Q2, this is Q3, and this is Q4. We'll see later on those two lines. If I were to rotate it and look at it like this, the lines intersect like a plus sign. When lines intersect like this, it's called perpendicular lines. And we're going to look at that later on. You can see on our list over on the left, that's section 6.6 and what makes lines perpendicular. We'll talk about parallel there too. That gives us how to do it. Okay. Peace.